What is Cisco CloudCenter? Cisco CloudCenter is an abstraction between your applications and the infrastructure that they run on. So you take your application, you model it to deploy onto Cisco CloudCenter, and then Cisco CloudCenter on the application's behalf will get deployed onto multiple different types of infrastructure. For example, VMware vSphere, Amazon Web Services, Microsoft Azure, and many others. Those tend to be the most popular, but there's many others that they can be deployed onto. You can also easily migrate an application from one environment to another environment. So you can take an application that you have deployed on VMware vSphere, move it to Amazon, move it to Azure, wherever you want to move it to. So it gives you that flexibility to just model the application once for CloudCenter, and then CloudCenter can figure out how to deploy it onto these various platforms. Because this takes care of one of the primary challenges that we have with application management, is that each application is typically tooled for a single environment. So if you have an application that's tooled to be deployed, and we're talking about automation, when I say tooling, I mean automation. So when you take an application and it's automated to be deployed onto one platform, that automation typically doesn't work for the other platforms. So if you have an application tooled for Amazon, you'll have to retool it to deploy it on OpenStack, or you have to retool it to deploy it on VMware vSphere, and vice versa. So that can cause some challenges, and that certainly will be some challenges in terms of being able to deploy your applications. And the reason for this is because that every cloud has different knobs. So they all, Amazon, OpenStack, VMware vSphere, Microsoft Azure, Google Compute, they all have different APIs. They have different instance sizes and types. They all have different underlying hypervisors. So VMware has ESXi, Amazon has Zen, OpenStack has KVM, Azure has Hyper-V, and Azure Pack and Hyper-V. So these are all different types of hypervisors. And there's different machine types, different names for networking constructs, and different nerd knobs. So when you tool your applications, when you start to do the automation process, you'll have to write a new automation process typically for every one of these. But because every cloud tends to start up a VM, every cloud essentially has the same images to boot: CentOS images, Ubuntu, Windows Server 2012, 2016, RHEL, etc. And every cloud has storage options such as object and block storage, and every cloud has networking constructs, IP addresses, subnets, public and private IP space, ACLs. So they're all providing essentially the same thing. So that's where CloudCenter comes into play, because CloudCenter will then translate all of these primitives so that you can deploy your applications. You just tool it once for CloudCenter, and then CloudCenter will then be able to deploy it for any of the supported platforms. And Cisco CloudCenter enjoys broad cloud support. On the private or on-prem side, several versions of OpenStack are supported, including versions from Mirantis and Red Hat and Cisco with Cisco MetaCloud. Of course, VMware vSphere is supported, several versions of that, and as well as Microsoft Windows Azure Pack and Cisco UCS Director. On the public cloud side, of course, Amazon Web Services is supported, as well as Google Compute Cloud, Google Cloud Platform, Windows Azure, Dimension Data, Alibaba Cloud, VMware vCloud Air, as well as several of the public cloud providers that are OpenStack based. So if it's OpenStack based, then it's probably also supported, so long as they adhere to the OpenStack APIs and have the proper versions. So in the public cloud, again, Amazon Web Services, Google, Azure, Dimension Data, NTT Data, IBM SoftLayer, and then anything OpenStack based. OpenStack Havana through Mitaka. So those are the OpenStack versions that are supported. vSphere 5.1 through 6.0 is supported. vCloud Director 5.1 through 8.10. UCS Director and Azure Pack UR6 and later. Operating systems supported. These are the operating systems that you can start up from Cisco CloudCenter. CentOS 6 and 7. RHEL 6 and 7, Ubuntu 12, Ubuntu 14, Windows Server 2008 and 2012, as well as common AWS services. Some of the features of Cisco CloudCenter, of course, probably one of the primary features is the ability to model. You model the application once, and modeling is figuring out how that application is composed, and then what components need to be installed, and how to automate the installation of those components. There's a graphical modeling tool based in HTML5, so no Java. And then you've got application and network controls. For deployments, 18+ cloud environments, you can track costs on public and private deployments. So one of the great things about Cisco CloudCenter is that when you do an application deployment, it's tracking the cost for that deployment, not just based on the cost on the VMs, but all the VMs combined. So it doesn't just track VM costs, it tracks application costs. And there's true lifecycle management on the application too, so you can have multiple versions, you can update the versions, etc. On the management side, again, tracking application costs. You can benchmark application performance for various cloud platforms and VM sizes. One of the most critical parts about aspects to doing public cloud, and which is very different than on-premises cloud and data center hypervisors and so forth, is figuring out what the appropriate VM size is. The various public cloud providers will, of course, charge you different amounts of money, and the bigger the VM, the more they're going to charge you. So your bottom line, the cost for an application is going to vary dramatically depending on the size of the VM you pick. So it's critical to pick the correct size for that VM. And one of the things you can do with CloudCenter is you can benchmark your application on a variety of sizes and on a variety of cloud platforms to see which gives you the best bang for the buck. And of course, there's full application lifecycle management. There's CI/CD. You can take an application through its entire lifecycle. You can integrate it in with CI/CD boards. There's a built-in CI/CD board that you can use as well. So it's really built for applications. And then administer and govern, there's role-based access control, there's multi-tenant administration, and then financial controls such as chargeback and budgets. You can set a budget for an application. So if an application goes beyond a certain allotment, you can do a couple of things like you can just send out an email warning, or you can actually terminate the application if it goes over a certain budget. So the automated application deployment, tool and application for CloudCenter deployed to any supported cloud. And then you can migrate an application. You can take an application that's running in one environment and move it to another environment. Part of that comes from the automation itself, and then part of it comes from the fact that CloudCenter abstracts away a lot of the platform-specific nerd knobs, so to speak. And that's really cool from a cost perspective. So if you're getting a better deal off of Amazon, you can migrate your applications that were running on Azure. So you can pit your public cloud providers against each other and say, let's say Amazon's running a special on a specific compute, so you can migrate your application from Azure or one of the other cloud providers, and vice versa. So you can put your application where it makes the most financial sense. It does track the application costs. So here's a screenshot here. You can set an expiration date for deployment, so that helps prevent some of those Amazon surprises when you if you carelessly leave a VM running on an on-premises deployment, you're typically not charged as an OpEx style of charging like you do with the public cloud. So if you leave a VM running, it's no big deal. But of course, if you leave a VM running perpetually on Amazon and you don't need it, you're just wasting money. And you can set budgets for applications and warn when that budget is close to being exceeded. So it works together with your different cloud environments. CloudCenter will sit in between your applications and your infrastructure, whether it's public cloud infrastructure or your own on-prem infrastructure. We can also integrate it with ITSMs and things like ServiceNow, Prime Services Catalog. So we can take applications that have been tooled onto CloudCenter, modeled onto CloudCenter, and then export them into Prime Services Catalog and ServiceNow. So consumers of IT resources can just go in and do that. And of course, using Jenkins and other DevOps style, you can, and utilizing the APIs in CloudCenter, you can do full DevOps style development for your applications. And of course, like I mentioned before, you have ServiceNow Integration. Take an application, export it into ServiceNow, it becomes part of the ServiceNow catalog. And that way you can have IT consumers of IT resources. They won't even have to go into CloudCenter. They can just go directly into ServiceNow, select an application, and then it'll deploy it onto whatever cloud environment that you have set up. And this allows developers, business users, and admins can use one integrated platform to quickly deploy and managing new and existing applications. And that's true for Mode 1 or Mode 2 applications. One of the concerns is you take these Mode 1 applications, these traditional enterprise IT applications, and the thought is we can't migrate it onto a Mode 2 platform such as Amazon, but that's just not true. Using tools like CloudCenter, you can take those applications and migrate them onto public cloud platforms. That brings us to what is an application. So what is an application? We start with at least one virtual machine. So what is an application? So CloudCenter deals with applications. So what is an application? So we start with at least one virtual machine. So an application is going to run on at least one virtual machine. And the virtual machine is going to have an operating system. And that operating system is going to have a configuration of things like what's the host name, where are the DNS servers, what's the IP address, do we get one statically assigned, or do we use something like DHCP to get our IP address, those type of things. Then we have the application components, such as maybe this is an Apache Tomcat server, so we're going to need Apache Tomcat installed, but Tomcat is just it's a Java app server, so we're going to need the Java code, so the jar files. And that application is going to have application-specific configurations. There's going to be a Tomcat config, application config. All these things need to be put together. Then we have the database and the database configuration. And the database is where we have the state. So the state is things like if you're a web store, then you're going to have the state of your inventory. What products am I offering? How many of each product do I have? What are the orders? What are the status of those orders? So that's all going to be stored into a state. And that's typically one of the things that we want to be most careful with, is to make sure we have a good copy, a backup, etc. of that state. Now, traditionally, when we do IT operations, this is all stored in a virtual machine, and we're going to back up that virtual machine, because if we lose this virtual machine, it's going to be very hard for us to recreate it. So we back up the entire virtual machine. We also have HA and multi-tier for these applications. So multi-tier applications are common. Those are things that have like a load balancing tier, something running Nginx. They'll have a web server tier, database tier, etc. And then each tier can have HA. So in this case, we've got a load balancing tier. We've got 2 Nginx servers running in active standby. We've got an application tier that's running 2 Tomcat servers running active. And then we've got a database tier that is running 2 MySQL servers, and those are probably running active standby. So we have these tiers, and again, we're defining an application. So this particular application has 3 tiers, has 4 virtual machines, and then we have to govern how those different tiers can communicate with each other. Is it just going to be wide open, or are we going to restrict communications? And then how does it communicate with the internet? What ports do we want to allow? Port 443 and port 80 perhaps? And then from the Nginx to the Tomcat servers, again, 443 and 80. And then from the Tomcat servers to the MySQL servers is going to be probably the standard SQL port, which is 3306. So all of this together, we are going to encompass this, and we're going to call this an application model. So this provides the blueprint to instantiate an application. It serves as the place of truth instead of the VMs and systems themselves. This allows for better operations, and this allows for quicker and better migrations. It also allows us to overcome one of the biggest deployment challenges, which is each application is tooled for different deployment onto a single environment. Now that we have a single place of truth, we have a single application model, we can use that application model to deploy onto CloudCenter. Then CloudCenter can deploy onto the various cloud environments. So one of the things that CloudCenter can do is migrate an application from one environment to another environment. So for example, probably one of the most common migrations that happens at first is from VMware up to Amazon or VMware up to Azure. So private cloud to the public cloud. So something to keep in mind, in an application, what do we care about? Do we care about the virtual machines? Not really. They're just the wrapper, the place to put the artifacts. What we do care about are the artifacts, the binaries, source code, configuration, the state, database, etc. Like I said, we call those the artifacts. Now, in cloud migration, there has been several companies, including an early version of CloudCenter rather. So when CloudCenter was a product called Clicker, and it was first starting out, they tried the vMotion method to be able to migrate a VM, an entire VM from VMware vSphere into something like Amazon. And this is an approach that's been taken by many different companies, including products like Intercloud Fabric and other products. Well, they essentially want to take a virtual machine and migrate it into Amazon unchanged, or at least from a virtual machine perspective. The same virtual machine that was running on VMware is now in Amazon. Now, technically it is possible to do, but it has been abandoned by every vendor for a couple of reasons. One is that it's expensive from a CPU and disk I/O perspective. The VMs need to be converted in flight or need to be stopped. The conversion needs to be done. I mean, think about it. You've got 100 gigs of disk. Let's say you've got a VM with 100 gigs. That's in VMware. That's a VMDK file. To convert that 100 gigs into an AMI image is going to take some time. Then you have to upload it. Moving a single 100 gig disk over a 10 gig link would take about 14 minutes. So it's going to take a long time to do these uploads for this. And this is just a single VM. And again, remember, we don't care about most of that VM. We care about the artifacts, the state, the configuration, but we don't care about the VM itself. So why move an entire VM if most of it is something you don't care about? So most of the products that do these type of migrations have abandoned the vMotion, the migration of a VM into a public cloud. So what CloudCenter does instead is it recreates the application environment into the new data center. So let's take an example here. I've got data center number 1 here on the left, and I've got Amazon Web Services on the right. I've currently got an application running. It consists of 3 tiers, and each tier has several VMs in it. So these will be VMs. So I've got my web tier, I've got my application tier, and I've got my database tier. So I've got 3 tiers. I've got a total of 6 VMs, and I want to migrate this application onto Amazon. Now, rather than do the vMotion, which we talked about, it was impractical for a number of reasons. Think about what we care about. We don't care about the VMs. What we care about is the artifacts. Artifacts are, if you recall back to a previous slide, artifacts are things like configuration files, personality for the VMs, binaries, source code, jar files, war files, and database state. And then we use the blueprint. So we've got the application blueprint, and it tells us how to build the app. It tells us all of the steps we need to take, all the VMs we need to start, the applications to be installed, and any services that need to be run. So when we trigger a migration, what's going to happen, depending on how we handle the state. But let's take a worst case example. A worst case example is it's an application where we're not doing any sort of synchronization of the database between multiple data centers. And so in order to preserve the state, we're going to have to shut down the entire stack. So this will mean taking a short outage, well, depending on how long it takes us to do the database migration. But if your application doesn't have the ability to synchronize a database across long distances, this is pretty much your only option. And it's very common for enterprise applications. So we're going to shut down the web tier. We're going to shut down the application tier, and that will freeze the state on the database. Then we're going to do a database backup. So some sort of database dump. MySQL dump is one way to do a database backup. All of the database providers or database platforms have a way to do some sort of database backup. So we're going to do a database dump into some sort of file, single file. And then, so this could be a SQL file. And then we're going to upload it to the repository. We're also going to start standing up identical VMs, or at least they'll be identical in terms of what goes on them. Of course, on Amazon, we're going to be starting different size VMs, or relatively the same size VMs if we want to, or we can change the size. So we're going to start up these VMs on Amazon. We're going to refer to the application model and populate them with the correct artifacts. And those artifacts are probably going to be on this repository here. Now, this repo could be, this is actually very common, as I mentioned before. This could be an Amazon S3 bucket. So it's a good place. It's a good way to store and retrieve files and artifacts. So we're just using the blueprint. We're using the model. It says, okay, start up these VMs with these operating systems on them, populate them with these configuration files. Since we're doing multiple tiers, we can actually set different security groups, is what they call it in Amazon, to let in specific ports and not let in other ports. So this will be our new web layer, our app layer, and our database layer. And we're not going to start the services yet because we don't have a database state yet. So once the database is successfully uploaded, then we're going to download it into the new data center. And we're going to, once the file is downloaded, we're going to do a database import. And that will populate the new database in the new data center. And then once all that's done, then we can start up the applications. Typically, we're going to leave these VMs, leave this application still instantiated in the old data center, because we don't want to wipe anything out in case this doesn't go well. But as long as this is up and running and we test it, then we can wipe this stuff out. Now, we're going to have to take an outage. If we have the ability to stand up multiple sites at the same time, and then we have the ability to do a database sync, let's say we did have that ability, then we would not have to take an outage. And that's a better way to do things, is to have synchronization rather than migration. But a lot of applications, especially enterprise applications, don't have that ability. So instead, we're going to have to take that short outage. However long it takes to do a database export, upload the database, download the database, and do a database import. That's still probably going to take less time than a full vMotion migration, which you could only do if these were both VMware data centers. And since they're not, we can do this. Think about it like this. Like, let's say I have a building. I live in Portland, Oregon. So let's say I have a building in Portland, Oregon that I really like, and I want to move it to Santa Clara, California. Well, I have two options. I could uproot the building and move it somehow across about 1,000 miles to move it to Santa Clara, California. That's going to be an engineering nightmare to take an entire building and move it from Oregon to California. Or I can just find the blueprints of that building that I like and then build a new building to the specifications of the old building, and then move some of the stuff by a truck that I care about, the furniture, plants, pictures, whatever. So think about it like that in terms of how we do migration. And this is really the way that we want to do migration for applications. And this allows us to This allows us to do migrations across different platforms, so we can move from VMware to Amazon, from Amazon to Azure, and that gives us much better portability for our applications.